Hey everyone, Michael Unger here in our ground station theater located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh, here with another edition of Ask an Astronomer, which means we get to talk to our astronomer, Marley Leacock. Hey Marley, how's it going?
It's going great. Not excited to wake up at 5 a.m. to watch the Canadian women's soccer match, but I will. I will do it. But it's
Okay,
good.
all
Yeah.
right. Wait, was that today or is that?
It's tomorrow.
I'm always get confused on the times there in Tokyo. So this morning is tomorrow there,
It's going the game is tomorrow morning at 5 a.m.
Okay, all right. So
Yeah.
we're set to go with some soccer action. Go Canadian soccer women going for the gold. But we are here to talk about space news. And if you are out there on YouTube land, hello. Put it into the chat where you are watching from. If you have any questions about anything to do with space, have you seen something up there in the sky? Have you read something in the news you'd like some clarification on? Put it in the chat. We are here for the next 30 minutes to answer those questions. We've got some big news stories that we're going to get to start off the show. Of course, if you have any questions about those, please put them in the chat. But, you know, Marley, I was just over in our observatory and I was covering for a breakout there. And I got asked a very random question and it kind of threw me a bit off guard. So I thought I'd ask you because I knew I was going to be chatting with you in a half an hour. So we are looking at the sun with our special filtered telescope. And the child asks, why is the sun so bright?
Nice.
I was a bit thrown off guard because I was like, oh, well, so I answered, well, the sun is large. It is generating lots of energy, fusing lots of energy, therefore creating lots of energy, therefore creating lots of photons. How would you answer that question?
Pretty much the same way, but it is the process of nuclear fusion that creates the sun being so bright. Nuclear fusion creates a lot of abundant energy, and the enormous size of it as well contributes to that. So all of that energy plus all those, bits that make up the sun moving around creates the opportunity for a lot of photons, which is what our lights see, so our eyes see. So a lot of opportunity for brightness for sure to come around.
So this is the best part of summertime when we get to see lots of kids. And I know lots of you out there, if you have kids and you're outside looking at the stars, and maybe, now's the chance to hear, some of those random fun questions you have from kids. So if you're an adult out there and you have some kids at home that are getting these random questions, come on into an Ask an Astronomer and you can just say, let's ask Marley on Thursday, and Marley can answer these
Well,
random questions
I can
for
do
us.
my best to answer. Some questions I still get, I have to think about them for a while because I don't quite understand what I'm being asked, but I will do my best every time.
I love it's just like the why of space. Why anything, But let's get to some of our big whys, which are why is there water on the moon and why is the International Space Station tilted? How's that for a teaser? Let's get to our big news stories of the week.
Right. So this week was big for the moon. Very happy for it. But some background science before we get into it is that we've known since about 2018, there was a paper published that determined that there was water ice at the moon's poles, which was very, very exciting at that time. The ice deposits were distributed in patches around the moon, and it could be ancient water ice. At the South Pole, most of the ice is concentrated at lunar craters, and at the North Pole, ice is widely and sparsely spread. So in this image here, which is from that paper, we do have the upper image being the South Pole and the bottom image being the North Pole. And the blue dots represent where the water ice was found. And the grayscale on the image, the darker it is, the colder is that surface spot. So what we see in this image is that the blue dots are kind of focused towards the grayer or the darker parts of the image. So the ice is concentrated to the darkest and therefore the coldest locations on the poles of the moon. And to get these images, they use an instrument called the M3 instrument, and it's called the Moon Mineralogy Mapper, is a NASA instrument. And it looked for 3 specific signatures to prove that there is water ice on the moon. It looked mainly for reflective properties we'd expect from ice, and as well as the distinct way ice molecules interact with heat and infrared light. And so just the fun fact, the craters where this is found, they actually never see sunlight because of the way the moon is tilted. The shadowy part stays shadowed at the poles, and so they never interact with sunlight. And so the warmest temperature in these areas never reach above -157 degrees Celsius, which is extremely cold.
That's pretty
But
cold.
pretty cool, but it was a big interest, a part of interest, because ice at the surface of the moon, at least within the top few millimeters of the water, could possibly be accessible as a resource for future lunar expeditions. So looking for water on the moon continued since 2018, and now there were a lot of thoughts as to how it worked and how it was there. So what they thought was that, okay, that water that forms during the night of the moon should burn off during the day. So this shows us the phase of the moon as we would see it from Earth. And it's interesting because daytime on the moon lasts about 27 days, and nighttime on the moon also lasts about 27 days, is how long day and night is. And so uh, during daytime, it can reach about 123 degrees Celsius. And at nighttime, it can reach about negative 248 degrees Celsius. So the temperature varies widely on the moon between day and night. And so it was thought that as the water ice formed overnight, water froze overnight, any water that was still there would have been burned off during the day, that the sunlight should have burned it all away, except we're in the poles where they never got sunlight. But what happened here is that they found new observations that water ice is present across a lot of the lunar surface, not just at the poles, and that it's present even during the daytime. And this goes against the previous computer models scientists have done of the moon, suggesting that the water ice should burn off as the sun comes overhead. And the ice in other places aside from the poles was confirmed by NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA, in 2020. So this led to a huge question of how is that ice there? Our previous thought was it should all be burning away anywhere where it reaches the sun. So how is this happening? A recent paper during this is a picture of the lunar surface during orbit in one of the Apollo missions. And two scientists, Bjorn Davidson and co-author Sonia Hosseini, who are both scientists at JPL, suggested that it was the shadows created by the roughness of the lunar surface created refuge for water ice. Because the many computer models used to determine these thoughts of, well, the water ice should just melt away, actually simplified the lunar surface. So it rendered it as a flat and featureless surface, like a very smooth ball, instead of having it with all the crevices and bumps and craters that creates roughness to the surface. And so because they took it all away, the surface far from the poles would heat up uniformly in the computer models. It all heat up the same amount during the daytime, making it impossible for water ice to remain. But as we know, the moon isn't a flat surface. It's rocky, it has lots of features, has craters, and all of those things. So Davidson and Hosseini took this into account, and they came up with a possible solution to how water ice is remaining during the day. So one of them, the possible solution was the water ice was actually inside impact glass that was created via meteorite strikes or within rocks on the moon's surface. So water was fused within it. So it can remain on the surface when heated, because it's harder for water to evaporate out of a surface when it's trapped inside. And so it would still be detected by the SOFIA instruments. So this diagram is showing kind of what that means. This is from their paper, showing the water molecules trapped inside the lunar surface. But the problem with this was that the observations showed that the amount of water on the lunar surface actually decreased before noon, or when the sun was overhead, and increases in the afternoon. So the amount actually changes as it goes on. It decreases and then increases. So this implies that the water is moving from one location to another, because it starts at one level, dips, and then comes back to the level it was. So the water is not necessarily going anywhere. It's just moving places. And this would be impossible if the water was trapped inside of lunar rock or impact glass. So they had to go back and try to determine a different solution to what was causing all of this water ice on the moon. And what they came with is that they revised the computer model to factor in the surface roughness apparent from images in the Apollo missions, showing the lunar surface with a lot of boulders and craters. So all of the shadowy areas that were still there even at noon. And Davidson and Hosseini explained that it is possible for frost to form in the small shadows there. So the moon does not have a thick atmosphere like Earth does. It has a very thin exosphere. And so no thick atmosphere means that it can't distribute heat. And so the shadow areas stay very, very cold, negative 210 degrees Celsius, and hot areas that are exposed to the sun can reach as high as 120 degrees Celsius. And they just stay those temperatures until the sun moves and it change the shadows of those things. So as the sun goes throughout the day, surface frost can accumulate in the cold, shadowy areas. And as the shadows move, that surface frost is exposed to the sunlight, and then it evaporates into the moon's exosphere, only to refreeze back on the surface of the moon and come back as frost in the new cold shadowed locations as the shadow moves as the sun passes overhead. So frost is more mobile than trapped water, which makes this process possible. It's more likely for frost to be in a shadow, and then as the sun moves and it becomes exposed to the sun, for it to evaporate and then refreeze on a different shadowy spot. And that's what this diagram is showing here. This is also from their paper. And this wasn't the first study to look at the surface roughness when looking at the lunar surface temperatures, but previous work did not take into account the impact of shadows on water molecules and the idea of frost. So this new study was really important because it helps to better understand how water is moved in the moon's exosphere and how the water cycle happens on the moon. And so there are more questions about it, obviously, because every new answer unlocks about 100 more questions. So Hassani is actually leading a team to develop extremely small sensors to measure signals from water ice. And these sensors are being developed to be able to be used on small landers, like stationary landers that simply land on the moon, or even on small autonomous rovers. So they'll be on the bottom and able to detect things about surface ice, sense signatures from surface ice. So this was really, really fun and really interesting. I was very excited to see, especially with all of the moon stuff ramping up. And Canada is developing a rover that will go to the moon in 2025. So my big question, and kind of fingers crossed, is hoping that one of these sensors will be put onto that rover and able to look more into the water cycle on the moon.
Oh, that's so interesting. We did already get some questions about this, but I thought we'd clarify a few things, because you did say that there is not an atmosphere to distribute heat, but there is an exosphere that is creating sort of this frost cycle on the moon. And we are going to sort of get into like these different levels. We did talk about sort of like the Kármán line and different sort of like spheres that the Earth has. But maybe could you just define sort of like what an exosphere and what an atmosphere is, just in relation to the moon, and then I guess we'll get more into it when we start talking about the ISS and Earth. But when it comes to the moon, what's the difference between the exosphere and the atmosphere?
Yeah, so the atmosphere, essentially is just like a thin surrounding, like a shell almost around a planet of different molecules and different gases and different materials around. And the exosphere is like incredibly thin and very far out. So the moon doesn't have enough gravity to hold an atmosphere like Earth does to be able to hold everything around it. Instead, the gases just slowly leave. And the further out they go, they do form like a little thin, incredibly thin shell, but they're constantly kind of like moving out. It's just that they keep getting replaced. Is kind of like the best way I can explain it. It's like this very thin, like the end of the atmosphere, quote unquote. Right. So there's like the moon, nothing, and then this thin nothing, and then this thin amount of material.
Yeah, and this is really interesting because, knowing that the moon has an exosphere, that's relatively new knowledge, isn't it? Like this was not always known, that the moon was capable of creating this frost cycle.
No, it wasn't always known. It wasn't necessarily considered. They knew that like there was water, and probably water on the moon, just from surface features and things like that. Like there had been, or there still was water ice, but it had never been, this frost thing is very new and not something that had been looked at before.
Interesting. So Pride was asking some questions about that, but also at any point could there have been flowing water on the moon?
They're not sure flowing water on the moon, because the current life cycle we have for the moon, like the accepted theory is that it was something impacted a proto-Earth, and all of that debris formed a rocky moon. And because of the lack of an atmosphere, it would be very, very hard to have running water because of the extreme, or flowing water, because of the extreme temperatures. It would be very difficult, and because the sunlight ranges from positive 210 degrees to negative 250 degrees, it would be stuck in that cycle of freezing and then gaseous and going between. So flowing water would be more difficult in how we've determined the moon to come to exist.
Oh, this is so cool. Got another question coming in about this. Do you think that they're going to take samples and test this water at some point? You had said that there's going to be some new rovers that are going to be driving around on the moon. Do you think this could be possibly safe for astronaut consumption?
That's what they're wondering. So that's a lot of it, is that So water, obviously, we need it to survive. We need it to live. And then also water is also in like rocketry and fuel. So whenever you see like those big rockets take off, like especially like the older rockets, when they took off, that big cloud is actually just water vapor coming out from the reaction between liquid hydrogen and liquid oxygen. And so if there is water on the moon and we're able to break it apart, it could be used as fuel as well as possible astronaut consumption or human consumption. But I do think that they will hopefully end up testing it. I know that the lander, I think by the Chinese Space Agency, that is on its way to the moon or has a planned mission, is due to land kind of at that South Pole or near the South Pole, where all of those lunar water deposits were clustered. So I do think that there will probably be some testing on it then, especially with how much rovers have, the technology has advanced with Curiosity and Perseverance and being able to take samples like that while being on the body. So I do think there will hopefully be some testing, and I'm excited to see what they find about it.
This does make my brain work. I don't know if this is bad for us in generally as humans, but this does make me think that perhaps there might be a company out there that might be motivated to find out if this so-called moon water is good for consumption. Say like a beer company or like a wine company. We've already seen Budweiser send up some barley. I said Marley, some barley up into space to try to test to see if they can make some space beer. Let's get some private money to further some of this testing. I'd have a space beer.
I mean, I don't particularly. I just think it's interesting that water could even be there. Is fun. How did it get there, anyways? I don't particularly care to drink it right away. It'd be the equivalent of like when Whole Foods did the asparagus water thing. Like that's what it is to me. Like there's a bottle of asparagus water and it's like $17. Like no, I'm excited at the possibility of it being there and the questions that it has.
Okay. So you're not going to be first in line for some moon wine,
No.
but they're going to do some testing and they're going to figure out if it's going to be safe first. Let's move on. We've got, wow, time is flying. We've got about 13 minutes. If you have any more questions about the moon, please put them into the chat. But there was another story. Let's get back to the Earth and talking about beyond our atmosphere in another orbital plane of the Earth is the International Space Station. As you can see, the module right behind me. And there was a news story recently that caused a bit of a tilt to the International Space Station. What's happening up there?
Yeah, so I got a lot of phone calls and texts from concerned friends and family about like what is happening on the International Space Station when this happened. So we have to kind of break it down. So first, there was this module called the Nuka module, and it was a Russian multi-purpose laboratory module that is actually going to provide a science laboratory, more sleeping quarters, and other capabilities for the Russian segment of the International Space Station. So the Russian segment of the International Space Station actually just decommissioned their old cargo multi-purpose laboratory module. It recently just burned up in Earth's atmosphere. It was a controlled descent burn. Everything's okay. And this was the replacement for it. So this was sent to dock with the International Space Station on July 21st, and it docked, I think, on July 29th, if I'm remembering right. And so the Nuka module is circled in this photo in the dotted line. The Soyuz MS-18 cruise ship is in the foreground. The Nuka module is in the background. So what happened with this is that it successfully docked with the International Space Station after some trouble en route there. There was a bit of engine trouble, but then it successfully docked and it was okay. And then a few hours later, it started to fire its thrusters, which is what ended up tilting the International Space Station. And people at Mission Control call this a loss of attitude control, not altitude, but attitude, which I thought was very funny because it made me think like the space station has an attitude problem. But what attitude means is the orientation of the spacecraft relative to Earth. And so attitude control is the process of controlling that orientation. And so it was actually declared a spacecraft emergency when this happened because now the International Space Station was moving. And it wasn't like spinning like a top. It wasn't going out of control, spinning very quickly. It was only going at about half a degree per second. So the astronauts couldn't even feel it. They didn't even feel it happening. They were alerted by Mission Control that this was happening. And what was wrong is Nuka had fired its thrusters and it was actually trying to detach itself from the space station, even though it had just docked with it. And so what happened is that it basically did a backflip and a half, the space station, moving its orientation. So it spun 540 degrees or 1.5 revolutions due to the thrusting of Nuka. So its thrusters pushed it and it did a backflip and a half. And so the module, they tried to stop it immediately, of course, but the module could actually only receive direct commands from the ground station in Russia, the parent agency controlling it. And the International Space Station was not due to pass over for another hour. And so Mission Control really had to figure out how they were going to fix this problem, because they couldn't just have the International Space Station doing backflips as it went around the Earth. So crew and ground teams fired counter thrusters on a different Russian module, Zvezda, and the Progress cargo ship. And so that those thrusters counteracting with the Nuka thrusters helped stop this the space station from flipping as anymore that it did. Also, about 15 minutes after firing, the thrusters just stopped. The Nuka module thrusters just stopped thrusting altogether. And so all of that, plus of the counteracting thrusting, helped get the team to get the station to stop moving. And then they were able to do a control thrust burn using Progress and Zvezda to get the space station to do half of a front flip to get it back into proper orientation. So basically did a backflip 1.5 times and then did half a front flip just to get back to where it needed to be in the proper attitude. So astronauts were never actually in danger. This was a really big concern because you hear the space station spinning, there's people up there, big problem, but the astronauts were never actually in danger. Ground control got in contact with them very, very quickly. I know there were early reports saying that the space station had only moved 45 degrees from its original position. That was right when the problem occurred and started happening, and it hadn't continued to do the flip. So that's how fast they were on top of it. It spun a total of 540 degrees, and there was already media releases when it hit 45 degrees. So ground control was already on top of it. The crew was already working to find a solution to the problem. And if it did get to the point where they had to bail out, they could actually all have suited up and bailed out of the SpaceX capsule that is currently attached to the International Space Station. And they could have undocked and removed themselves and come back to Earth safely that way if needed be. So there wasn't a huge amount of danger, and now everything's okay and working normally, and nothing was damaged in the flips. So everything's all right.
Well, this does bring up some questions as to, I suppose what things could have happened, maybe not dangers, but so if it was, say, continuing to this flip, the astronauts themselves wouldn't have known because, of course, they're not, attached to a floor and a ceiling. They're, of course, floating in that sort of microgravity state inside the space station. But what would have happened to the space station itself if it would have continued to flip? Would it have lost its say, attitude and started to descend or start to move away from the Earth?
It not necessarily would have started to move away or like float away or get closer to the Earth. It's more so all of the things attached to it. So the International Space Station is actually quite big, and there's a lot of things sticking off of it at different angles, right? You have like the main modules, and then you have modules coming off, and then you have solar arrays coming off. So a lot of it was potential damage to the exterior part of the space station. We saw like a couple of weeks ago that Canadarm got a hole in it from space debris. Punctured a hole in the Canadarm or the space station. It's okay, it's fine, but there's always that risk happening, especially if it's not at the right orientation. So because it's in a specific orientation, mission control and ground control know where it is relative to everything else that's also up there, right? And so if it moves that orientation, it becomes a risk that something may hit it, and something may hit a specific solar panel or a solar array or one of the wires coming out of it. And so that becomes more of the problem, as well as everything when the space station, things dock to the space station, it's in a specific orientation as well. And same when they undock. So if they ever had to undock something or they had to even bail out in an emergency, it requires a lot of extra steps to get that done if you're still spinning continuously, because that motion will pass on to whatever leaves.
Really interesting. Well, glad to hear that all of the astronauts are safe up there. Always a little bit complicated as we go up there. Maybe something to rethink about with everyone going up there with space tourism. That's been the big story of the past month, which will continue to happen over the next year. We've got our last 5 minutes left. If anyone out there on YouTube land or in Telus Optic, well, you can't ask questions on Telus Optic, but come on in to YouTube next in 2 weeks. Of course, thank you all for joining us here. We changed up our schedule, mainly because next week we have a big sky event that's happening. So we wanted to change up our schedule. But if you are out tonight and you're looking up at the stars, what can we possibly see? And then we'll get into what the big event is next week in a few minutes.
Yeah, so coming up tonight, what you can possibly see, yeah, it looks pretty clear right now. Hopefully it stays that way. Jupiter and Saturn are up. They are up in the evenings after sunset, and they both rise in the east and set east-southeast and set in the west-southwest. Saturn will be to the right of Jupiter, and they look like bright stars in the sky. So pretty bright, but they're closer together, and those are actually planets. If you have binoculars and you take a look at Jupiter, you have the potential of seeing 4 other points of light by Jupiter, which are the Galilean moons, which are very fun to see. If you look at it night after night, you can actually see them moving. They'll be in different locations. And so that's always fun to do. As well, you'll be able to see the summer triangle. That's up now as the summertime asterism, which is bigger than you think. I remember seeing it for the first time and I was like, oh, no, okay, yeah, that's pretty big. It takes up a good part of the sky. And just look for Vega first. It's the brightest star when you look up. Look straight up and it will be Vega, and then to down from Vega, Altair, and then to the left and a bit down will be Deneb. So just keep an eye out for that big triangle in the sky.
Awesome. And of course, if you want to learn more about one of Jupiter's moons, if you head back to last week's Ask an Astronomer, talked all about Ganymede and also the potential of finding some water vapor there. But next week, Marley, we have 2 events. On Wednesday, we are going to be online. We are going to be reaching out to all of you remote folks, talking about the Perseid meteor shower, talking about it in a couple different perspectives. Marley will take us through sort of navigating the night sky in a little in depth. And we also have a special guest, Dr. Brittany Carr from UBC, who is an eye scientist, and she's going to talk about how our eye adapts, something that I've always talked about with our guests here, you know, how we want to use our dark adaptation using red light, not white light, but I've never actually really thought about what is actually happening. Why does our eye do that? And think about that in a little bit more in depth. So come join us next Wednesday evening for that. And then on Thursday evening, we are physically going to be in our backyard and we're going to use the natural planetarium. That's the real nighttime sky. And we'll be looking up at Vega, Deneb, and of course, the Perseid meteor shower. So as we'll be out there, Marley, you'll be out there, and our observatory will be open. Hopefully we can see one of those planets, either Jupiter or Saturn, with the scope. And of course, Friday nights, if you're ever free, come on down. We are open every Friday night so that you can possibly see those planets as well. All right. We've got last 2 minutes, and we have one final question. Back to the International Space Station story. So the question from MyCap19 Nerd asks, why did the station not notify the astronauts that this was occurring? Maybe they did. Maybe they didn't think it was that worrisome to bother them. And why did they have to find out from their counterparts on Earth?
Okay. So I think the confusion is that the Nuka module doesn't actually have anybody in it. And so it was by itself launched from there. And so when it docked, it was fine. And then it started to spin. And the astronauts didn't notice that was happening right away. They don't feel the spin.
Okay.
They were also dealing with other tasks on the space station. It's also very big. So they may have been in different parts and not noticed right away. But then they did get an alert from the people on ground who continuously monitored the space station. Like that's their job, is to continuously monitor and make sure that it's okay. So the astronauts were alerted as soon as possible as to what was going on, which is pretty quickly because it was a spacecraft emergency, as they say.
Right. So I guess that they're probably the message was, hey folks, we've got a bit of an issue with the new module. We're going to try to deal with things on our own end. For you, you're going to be fine. Just keep monitoring. Everything's fine. Don't worry. Everything's fine. It was
a combination of, hey, we know there's a problem. Now you know. Here's a solution we may have. You may need to do this up here. And so it was a team effort. People, because not all of the ground commands can be executed. Some can only be done up on the station. And so if they needed to physically turn something on or move something, ground tells them to do that. And so it was a back and forth, but it ended up okay. They're trained for things like this. So.
Yeah, that's really interesting. And also really interesting to think about how, because of where it was in orbit, that the scientists in Russia wouldn't have been able to do anything at the moment. And that's one of the reasons that the International Space Station is up there, is for collaboration for different countries around the world to all working together. And it has been a great collaboration, and hopefully this will continue into the future as we go out to the moon with the next iteration, which will be the lunar station. So looking forward to that. Thank you so much, Marley, and thank you all for joining us for another edition of Ask an Astronomer. Like I said, we'll be back on a new schedule in 2 weeks, so 2 Thursdays from now, but we'll be having those per-seat events next week, so look out for those on our website. You can get tickets there, spacecenter.ca. Until next time.